Hi friends, this video we are going to solve this problem. So they given the 3 points, it's mapped to 3 points. I want to find the bilinear transformation first, then I want to find the invariance. Invariance by nothing that it's a fixed points. I want to calculate. So I know that bilinear transformation has at most 2 fixed point other than the identity transformation. So it is given is not identity transformation. So maximum I will get 2 fixed point. That is in my mind. Okay, now we can proceed. How we can solve? First step, I know that bilinear transformation preserves cross ratio, correct? So I am going to use that result only. So that meaning is what? So minus 1 is mapped to 0, 0 is mapped to I, 1 is mapped to 3i. So EZ minus 1, 0, 1, this cross ratio equal to W 0 I comma 3i. So we know the what is the cross ratio formula, correct? What is the cross ratio formula? The cross ratio formula I want to write it. So EZ1 comma EZ2 comma EZ3 comma EZ4, 4 are distinct points. This is equal to EZ1 minus EZ3 times EZ2 minus EZ4 divided by EZ1 minus EZ4 EZ2 minus EZ3. So this is the cross ratio formula. We know that. So I apply EZ minus 0 is EZ times minus 1 is minus 1 divided by EZ minus 1 minus 1 0 is minus 1. My right hand side is W minus 3i. So W minus I. So W minus I minus 3i divided by W minus 3i 0 minus I. So this is the case. So now this is minus 2 times EZ divided by minus EZ minus 1. So this minus is cancel. Here is you will get it as this minus will cancel, I is cancelled. So 3 times W minus 3i divided by W minus 3i. This is our point. Now you want to multiply the cross multiply. So 2 times EZW minus 6 EZI equal to this case 3 WEZ minus 3i EZ minus 3W plus 3i. Now you want to make it is a W on one side and the EZ is one side. So 3, this implies 3 WEZ minus this case coming in 2 WEZ minus 3 W equal to minus 6i EZ. This is going that side means plus 3i EZ plus 3i. So now you commonly taken this is it's a WEZ only will come. So W you taken means EZ minus 3 we get it. W equal to EZ minus 3. Here you will get it as EZ you can't take commonly, you will get minus 3i So you will get it as 3i times 1 minus Ez. So clearly we get it. So I made mistake somewhere. So 2EZW minus 6EZi equal to 3WEZ, 3IEZ minus 3W plus 3i. So it's automatically WEZ minus 3 equal to, this is 3IEZ. Yes. Here is the minus term only will come, correct? Because I will make to this side. So this is minus 3i. So here also you will take minus 3i. So you will get 1 plus Ez. So this implies W equal to minus 3i 1 plus Ez divided by Ez minus 3. So if you want to minus, so W equal to 3i times 1 plus Ez divided by 3 minus Ez. This is also fine. So this is our required bilinear transformation. Anyhow, I want to cross check it because minus 1 is mapped to 0. So Ez is equal to minus 1. What is the W? Minus 1 means automatically 0. So Ez is equal to 0. Ez is equal to 0. Numerator is 3i. Denominator is 3. So W equal to I, we get it. Ez is equal to 1. 1 means 2. Here is 2. So 2 will cancel. W equal to 3i. So clearly it satisfies all the, we verified, correct? So these are the verification. You no need to do in the exam point of view. You simply I want to check it. Verification. Now I want to find the fixed points. So how to, what is the fixed points? So f of Ez equal to Ez. So f of Z not equal to Z not, those points we call as a fixed point or invariance point. So now I want to find Wez equal to 3i Ez plus 1 divided by 3 minus Ez. So we multiply 3Ez minus Ez square equal to 3i Ez plus 3i. Now you can write it as one side Ez square plus 3i Ez minus 3Ez plus 3i equal to 0. So now Ez square plus 3 times 3i minus 3 times Ez plus 3i equal to 0. So Ez equal to minus 3i minus 3 plus or minus square root of this is square, correct? 3i minus 3 the whole square, 3i minus 3 the whole square minus 4 times, so 12 times I divided by 2. So this is, you will get 3 minus 3i plus or minus square root of, so this is, you will get it as minus 9, this one is plus 9 minus 18i minus 12i divided by 2. So 3 minus 3i plus or minus square root of 13i will come, minus 13i will come divided by 2. So this is, you will get it as 3 minus 3i plus or minus square root of minus 13i divided by 2. This is my Ez. So now you can find minus 30 square root of 5. You can easily get the result is, so how you can use means, I am using the result, you can use the two ways. One is the chess formula you will apply, otherwise you can directly use the algebraic result. So that way only I am going to do here. Suppose, so I want to find, so this part only I want to find, correct? This part, this one I want to evaluate first. Later is very simple only. So I take z0 square equal to 30 minus 30i. So z0 equal to my square root of 30i. So I want to evaluate what is my z0. That is my aim, correct? So I will take z0 is x plus iy. So z0 square is x square minus y square plus 2 times I xy. So clearly x square minus y square is 0 because there is no real part. So 2xy equal to minus 30. Now x square plus y square the whole square, what will come? X power 4 plus y power 4 plus 2 times x square y square formula will get. So I can write it as this guy is x square minus y square the whole square plus 4 times x square y square I can write, correct? Because this is x power 4 plus y power 4 minus 2 x square y square will come. So suddenly this guys will come. Okay. So what is x square minus y square whole square is x square minus y square is 0. So 0 square is 0 plus, if I want to take the square is, I will get it as 900. So x square plus y square the whole square is 900. So only positive value will be taken. So x square plus y square is 30. So now this is the equation number 1. This is the equation number 2 you consider. So 1 plus 2, 2x square equal to 30. So x square equal to 15. Okay. So this implies x equal to square root of 15. Now you apply in this guy to here. So what will comes? Y square equal to 15. So this implies also y equal to square root of 15 only, because 15, 30 minus 15 is 15. So y square equal to 15. So this implies y equal to 15. So that is if z0 is 50 square root of 15 plus I time square root of 15. This is, so now my z equal to 3 minus 3i divided by 2 plus or minus square root of 15 plus square root of 15i divided by 2. So one fixed point is z1, that's a fixed point is 3 minus 3i divided by 2 plus square root of 15 divided by 2 1 plus I. z2 is 3 minus 3i divided by 2 minus square root of 15 divided by 2 1 plus I. These are the two fixed point of the given transformation. So if you are compared, take the real part, 3 plus square root of 15 divided by 2 minus 3i plus square root of 15 divided by 2. So you can club into real and imaginary part separately, you can make it. That way also you can find. So this is fine. So given function is they give the 3 points mapped to 3 points. Using the cross ratio, we get the bilinear transformation. Then finally we check the invariance points. I hope you understand how to form the bilinear transformation using 3 points of mapping and how to compute the fixed points also. Thank you for watching this video.